Alright guys, hello and welcome. We got a little trip down memory lane here today. As a supplement to 3.5 is, in addition, this is from the last book just to kind of help us before we jump straight into parallel and perpendicular equations of lines. We are going to review some concepts from Algebra 1. That first one being the slope. Alright, change in y over change in x, rise over run, was taught to you many different ways. Today let's practice that and a little bit more. So problem 1, what is the slope of B? So B is the downhill slanting line. We have 2 points. So that's all we need. We have 2 points. We can determine the slope. We take the change in y. So 2 minus a minus 2 on top of negative 1 minus 4. Getting a grand total of, when simplified, to negative 4/5. All right. Part B, D, a vertical line. So all vertical lines, of course, have a slope of undefined because you have 0 in the denominator. Can't divide by 0, so therefore an undefined slope going straight up and down. Alright, pause the video here and try to got it. Alright, welcome back. So hopefully you got 4/3 for A and 0 for C. Horizontal lines, of course, all have a slope of 0, uphill, rise 4, run 3. Alright, here we have just a little friendly reminder of the positive, negative, 0, and undefined slopes. And let's talk about Hoy-Bucks real quick. Hoy-Bucks was an acronym that your algebra teacher probably used to help you remember that horizontal lines have a slope of 0 and the equation is y equals whatever. So horizontal, slope 0, y equals, whereas vertical lines, v, have a slope undefined and the equation for the line is x equals, which we'll see a little bit later. So Hoy-Bucks is there for you as a mnemonic device to help you remember what goes with what in the world of slopes. Now, moving on to forms of linear equations. We have 2 forms we're going to analyze in this section, slope-intercept form and point-slope form. And slope-intercept is the y equals mx plus b that you guys are familiar with, where m is the slope and b is the intercept. Then point-slope form is another form of an equation for a line. And basically you plug in the coordinates of the point that you know, x coordinate here, y coordinate there, and the slope. And you can, it's a perfectly acceptable way, but typically we take this and then turn it into slope-intercept, which we'll see here a little bit later. All right, in problem 2, we're going to talk about graphing. So let's graph these bad boys. Now, in the first one, we're going to graph from slope-intercept form. So the slope is 2/3 and the intercept is 1. So we start with the intercept because that means that's where we hit the y-axis. So this line is going to hit the y-axis at 0, 1. And then the slope is 2/3, so that means I go up 2 and then over 3. So it's that simple, my friends. Now when you're in point slope form, like in problem B, it's a little bit, it's different. You could switch it back into slope intercept if you want, but you don't have to. You can just look at what's accompanying the y and the x, flip the signs on each. So my x value is -3, my y value is +3. And again, if it's going into the equation, it's negative, so when it's coming out, you got to flip the sign as well. So we got a lot of arrows going on here. So again, I analyze what is next to x. Since it's +3, I make it -3. Then I analyze what's next to y. Since it's negative, I make it positive. And then again, I use the slope, which I can find inside the equation. So now my point is -3, 3 that I start with. So I go 1, 2, 3, 1, 2, 3. And then my slope is -2, so I go down 2 over 1, down 2 over 1, down 2 over 1, and there's how we sketch that. Just remember, negative slope's going downhill, positive slope is going uphill. Pause the video here and try these two. All right, welcome back. So we should have a little something like this. slope of 3. And then in this one, the point that I'm going to use is 4, 2. I flip that, and then I flip that. Slope is negative 1/3, so 1, 2, 3, 4, 1, 2, 4, 2. And I go down 1 over 3. So my slope, my equation, my line looks like that. All right, moving along to writing equations of lines. Yeah, I'm making a video. Oops. All right, so you gotta see what you're given. If you're given the slope and the intercept, then you have to use slope-intercept form when you plug it in. So just plug the slope in, plug the intercept in, and you're done. Now in part B, you're given a point and the slope, so you should use point-slope form. So plug the x in, plug the y in. I mean, you're gonna gotta flip the sign. So if it was negative, now it's positive. If it was positive, now it's negative. And simplify. So now we can take this equation and we can put it into slope-intercept form very easily. So just distribute the 2, and then we can add 5 to both sides, and then that is the same as that, just in a different form. All right, pause the video here and try the got it's. All right, welcome back. So the first one's easy peasy. Plug the slope in, negative 1/2 on the x plus 2. And then in this one, we want to just plug the coordinates in. So y, flip the sign, so that's minus 4, equals the slope times x, flip the sign, plus 1. And again, to put that into slope-intercept, distribute the 3, so we'd have negative 3x. That would be negative 3 when you distribute, and then you would add 4 to both sides, so y would equal negative 3x plus 1. All right. On my quiz, you can leave it like this. If it's on a SAT or multiple choice, you might have to switch it into slope-intercept. All right, now this is kind of a pain whenever you are given 2 points and asked to write an equation of the line. Either form, you're going to need the slope. So the first thing we got to do is find the slope. So it's going to be 5 minus 1 on top of 3 minus 2. So that's 6/5. So now once you have that, pick either point. I'll just pick 3, 5, and plug it in. So now I have y minus the y value, which was 5, 6/5 x minus the x value, which is 3. All right, and then you could switch this, but it's got fractions, and I don't really feel like it. So if you want to, you go nuts. You can switch it. All right, pause and try the got it. You're just using the different points this time. All right, and here we go. So now I take y minus the y value, so I got to flip the sign. So now it's plus 1. 6/5 is still the slope, and then x, flip the sign on the 2, so plus 2, and there you go. All right, final problem today. We have what are the equations of the horizontal and vertical lines through the point 2, 4? So, got this point 2, 4, there's one vertical line, one horizontal line that passes through it. And what are the equations for it? Well, all vertical lines are x equals. So what does x equal at that point? It equals 2. So all along this line, x equals 2. Similarly, the horizontal line is y equals. What does y equals? All along that line, y equals 4. So there you go. Y is 4, x is 2. Pause the video for your last got it for today. All right, and welcome back. What are the equations for the horizontal and vertical lines through 4, negative 3? Well, the horizontal is always y equals. So what does y equals there? It equals negative 3. The vertical line, what does x equals? That is positive 4. And part B, can you write an equation of a vertical line in slope-intercept form? No way, Jose. Why? Because mx plus b, the m for a vertical line is undefined, and there's no way to express that in an equation. So nope, vertical lines are x equals, they're kind of playing their own game. Horizontal lines you could, because the x value, this entire term would disappear when m is 0. So that's why it's just y equals whatever the intercept is. All right, so that's a wrap on the supplement from 3.5. Peace!